Hi guys, this is experimental chemistry and we are looking at apparatus commonly found in a chemistry lab and their uses. A weighing balance, or more specifically a digital weighing balance, is used to measure accurate masses. So when we use a weighing balance in a lab, we use it twice because we measure the initial mass or we set the initial mass at zero. That is also possible using the tear facility on the weighing balance. So in order to measure the mass of a test tube, for example, we cannot place the test tube on the weighing balance itself because it would fall off and break. So what we do is we place a beaker on the weighing balance, and we can do two things. Either we press tear to set the value at zero and then place the test tube inside the beaker in order to contain the test tube, and then the mass of the test tube would be displayed in the digital scale and we can record that mass. However, we can also do the same experiment without using the tear facility. We place the beaker on the weighing balance and note the reading of the mass of the beaker. Then we add, or rather place a test tube inside that beaker, and then look at the increase in mass. The difference between the two masses would give us the mass of the test tube. Similarly, if we are going to measure the mass of a liquid or mass of a solid, we would need the help of a container or a containing piece of apparatus. So a weighing balance is almost always used twice. So the least count in a digital weighing balance is based on the decimal places that the weighing balance show. The most common weighing balance in a chemistry lab is a weighing balance measuring to 2 dp. However, there have been instances in which we have weighing balances measuring to 1 dp, 2 dp, 3 dp, and 4 dp available inside labs. So the errors in such pieces of equipment depends on the decimal places that can be measured using the weighing balance. So the error in a single reading would be half of least count, and the least count for a 1 dp weighing balance is 0.1. So half of least count would be 0.05. However, since it would be used twice, then the least count would be equal to the error of a weighing balance. So a 1 dp weighing balance would have an error of a single read of a complete reading. For a 1 dp weighing balance, the error would be 0.1 grams. For a 2 dp weighing balance, it would be 0.01 grams. For 3 dp, it would be 0.001 grams. And for 4 dp, it would be 0.0001 grams. So these are the errors that are there in using the weighing balance measuring to 1 decimal place right up till 4 decimal places. However, as stated, the most common weighing balance in a chemistry lab is the one measuring to 2 decimal places. So in order to calculate the percentage error using a 2 dp weighing balance, we would take the error that is there, which is 0.01, and we divide it by the mass taken. Let's suppose that the mass that we are using measures to 25 grams. So the error would be 0.01 divided by 25 and into 100, giving us a percentage error of 0.04%, which is a very small error. So this error makes certain that the mass measured using a digital weighing balance is highly accurate. One more thing we need to remember is that the error of a weighing balance is fixed. So the greater the denominator would be, which means the greater the mass taken, the lesser would be the error, and vice versa, which means the smaller the mass taken, using the weighing balance, the greater would be its percentage error. So in order to reduce the error during an experiment, we can use a larger mass of a substance that we measure, so that its accuracy would increase.